flurry dies down. But hope you guys had a good lunch and you're not too sleepy. I think my oh, come on. Bad lunch? I never had any lunch actually. I was just up and preparing. But anyway, hope my tricks can keep you awake for this lecture. So, all right, let me begin. Welcome one and all to Black Hat in Las Vegas. It happens to be my favorite conference and I hope it is yours too. My name is Saumil Shah. Just to introduce myself, few of you must be knowing me, few of you don't. But I'm the director of a company called NetSquare Solutions, which is based in India. I travel a lot. And during my active time, I write code. During my passive time, I write security methodologies and tricks. And this is what happens when you write too many things in a short time. So all you guys using laptops, do take it easy. I don't wish this upon my worst enemies. But all right. So today, I'm going to present some more tricks regarding automated web assessment tools, especially how to defeat them. But I definitely don't want my talk to be misconstrued that I'm slamming down on all the assessment tools that are out there. The purpose of this talk is to, expose the, wow. And for a minute I thought, what's up? Okay. Anyway, so what's this talk all about? This talk's about not beating down on any particular tool or tools, but identifying the boundary where automated web assessment or even any automated assessment can go to and where it leaves off. And then there's still some further distance to go. So I definitely want to illustrate the limitations of automated assessment tools and automated assessment techniques. Like the idea is, don't rely on everything that's done by tools. You definitely need manual intervention and manual analysis that can never substitute for any tool report. This talk is based on my past experience. I've been writing web assessment tools since 2001. It's been 3 years since I wrote them. I wrote 3 big crawling engines. By big, I mean non-significantly sized crawling engines. Put in a lot of effort in trying to get the accuracy count up, trying to eliminate all false positives. Came up with a few new techniques, server fingerprinting, which I presented all of last year in different black hats. Now you have a tool called HTT Print, which we are the proud authors and owners of, and that tool's going to see some more revisions as we go ahead. I also came up with a technique for determining error signatures. How do you tell if this is a good page from a bad page without looking at HTTP response codes? I presented that during my talks last year on a title called Page Signatures. Looking at all the experience that I have with crawlers, I figured that there are still some areas where crawlers can't reach. And what are those areas? What are the limitations? And I've encountered limitations with a few sites. So this talk is centered about all these limitations. And if you guys want to implement crawler defeating or crawler fuzzing on your sites, on your applications, it's actually very easy to do so. During the end of the talk, I will introduce a set of code applications that I've written called PHP Guard, which you can apply to any PHP-enabled site. It's PHP code, so you can include it on your PHP applications and make sure that none of these robots or crawlers actually start knocking up your site. Right, so security again is a cat and mouse game. Today we have crawlers, tomorrow we come up with defeating crawlers. Tomorrow we'll come up with defeating crawler defeaters and so on. So this will just break open identify some more ideas of research. I definitely look forward to all the question answers you have. Few of the web application security luminaries are sitting here. So pardon me if I slip up. In certain areas, I'm not really as sharp as you guys think I am. Okay. And the code for PHP Guard will also give more insight to developers. How do you actually use secure development techniques in applications? Anyway, enough of the introduction stuff and all that sort of thing. Right. So now sorry, any questions? It's too early to have questions. Okay. So let's go on with the next, the introduction of the topics itself. First, let's just recap everything that is about automated web assessment. What is the theory? How does automated web assessment work? Or for that matter, how does any automated assessment work? You have Nessus, for example. It's a very good automated assessment tool. First thing it does is target identification, then selects the targets, expands upon them. You do your IP live hosts, you do your port scans, you identify your services, you try to identify the versions of the services, any vulnerabilities associated, you drill down forward, you find out all the attack points, possibilities, you know your test vectors, you try the test vectors, and generate a nice big beautiful report in HTML, XML, and PDF, or whatever you want. And you have, at the end of the whole automated test, you have this collection of problems that were detected. In the same theory applies to web assessment. If you're trying to assess a web application, how would you generally go about doing it? You'd first of all test the web server, test the platform that it's running on. Next, you'd go and crawl the web application. By crawling, you first start with the main page. You recursively suck down all the other HTML pages that get generated along the way. You pretend you're a human, you click on each link, you visit each form, you try each URL. Take all the response that you get. From the response, you'll get some more links. So you keep going further and further. Once you have all your application resources gathered, then you begin with the process of analyzing them. So how do we analyze it? First, we map the application. Okay, this area looks like a login area. This area looks like a transactions area. This area looks like a report area. So you map the application. Then you try and find out the attack points. Like which of these resources look really juicy. All resources ending with .html, the static stuff, throw away, nothing can be done about it. If you have resources which have a form on it, or you have some sort of a query string with, say, ID is equal to 3 or ID is equal to 4, those types, or you have some input fields, input stuff lying there, you can identify that, okay, we're going to try SQL injection attacks over here. We're going to try cross-site scripting attacks over here. You identify all your attack points. You also identify potential authentication points. If you see pop-ups which ask you for a login name or a password, or you see forms which ask you for a login name, password, you can try doing some sort of brute force account enumeration. Once you have all these points identified, then you go ahead and perform the actual attacks. At the end, you also look for some known vulnerabilities. So this is the whole process of automated assessment. Now, what does when you're implementing an automated assessment engine, what are the components that you need to implement? I mean, first and foremost, you need to implement an HTTP client, a client that's able to connect to a web server, issue HTTP requests, receive HTTP responses, and parse them. You should be able to handle normal clear text HTTP connections or SSL-driven HTTP connections, etc. Then, most importantly, you need a lot of testing logic. Whenever you receive responses, you need to pass them through a lot of testing logic to identify what is valid and what's not valid. And now the fun begins. In the web realm, responses are not so cut and dried as the normal OS or network security testing. If you have a FTP server, you know the FTP responses really quickly. You can identify that pretty quickly. You can identify banner strings. There is not too much of variance that happens in data returned through normal network services testing. Coming to HTTP data can vary a lot. The HTTP header can be varied completely. Users, administrators, and developers and administrators both have a lot of control over HTTP responses. Like you can very easily set up a website which says return all 200 OK responses for all pages not found. It doesn't necessarily have to be a 404 response. You can just say it's 200 OK. If you have a dumb crawler, it's going to think that, oh, I'm finding all these wonderful vulnerabilities. This site is broke like anything, and these people suck. But that's not really true. That's just because you have tricked the crawler pretty quickly with a 200 OK response. So now when you're implementing testing logic, there's a lot of hurdles to be overcome. You can't really believe what you see, so you have to implement some sort of heuristic techniques or fuzzy techniques or different sort of techniques to classify what are errors and what are not errors. If you can't do that successfully, you'll end up into a whole slew of false positives. You create a big mammoth set of information and which is pretty useless and meaningless. Modern crawlers actually end up identifying error signatures first before beginning crawling. So the whole idea is before you get into crawling the web application and classifying the resources, you perform a few tests. You perform a few quick tests. You try to look for pages or resources that are not really there. Like one of the things I do is I make a request for anti-disestablishmentarianism.html. This string is not going to exist. Depending on the response I get back, I will know what an error signature looks like. So if the first response is 200 OK, then I know, okay, this site is configured to lie. I will now just treat 200 OK as I'll have to do further testing on all 200 OKs. So then what I do is I end up getting an error signature. If you want more details on error signatures, I will refer you to my previous talk on page signatures and advanced assessment. I think the talks are all archived on the Black Hat site. You can just pull down the PPTs and look at it. But in essence, error signatures work in the following manner. You send a request for a non-existent page. Whatever you get back, you derive some sort of a signature from it. You can derive a string-based signature or a fuzzy numerical-based signature. There's many techniques of deriving such error signatures. I've come up with a technique which does some structural analysis of HTML, based on certain signal processing techniques. You do Fourier transforms of text strings and all that stuff. But even these fancy techniques can be defeated, which is what I'll show you later on. Once you get the signatures, then when you keep going ahead, when you do your assessment, you compare every response back with this signature to see if it's an error or not. So then you have some metric of determining what is an error and what is not an error. The other ways of doing it, you send a malformed HTTP request. Whatever you get back as a response, you can treat as a signature for 400 or 500 HTTP response codes. So then you proceed further by identifying signatures from the responses. You don't rely on the response codes at all. So that's the whole idea of error signatures. One of the biggest problems with crawlers, one of the greatest drawbacks of crawlers are false positives. The more the false positives, the worse the crawler is. You don't really want to do automated assessment if it spits out a whole lot of false positives. So how do you try and eliminate false positives? One of the techniques you can use is compare error signatures or compare page signatures. You can do string comparison even further in there. You can try and do some regular expressions comparisons. You look for certain patterns and confirm that, okay, if this pattern exists, then I have what I have indeed. Like for example, if you're looking for a browsable directory, you look for string patterns like index of slash, and then you have a dot, and a following by a huge directory list. If you don't get such a response, you say, okay, I got something, but this does not look like a browsable directory. Let's throw it away. Or you may have certain heuristic techniques. And you can do mathematical stuff like Levenstein distances or Euclidean distances. But all that geek stuff I'm not going to get into right now. So I just talked to you about some of the components that go into building a crawler. Right? What are the key components of building an automated crawler and automated web assessment engine? These are the principles that we would attack when it comes to defeating crawlers and when it comes to confusing them. So it's important to keep these concepts in mind, and then we'll see what causes them to break. What are the error conditions beyond which they cannot perform? So first now let's take a deeper look into an HTTP crawler. What is a crawler? First let's try and enumerate what are the properties of a crawler. Then we'll see what a crawler is not. Where does a crawler have its limitations? And then we start seeing what can go wrong with things. A crawler is a functional HTTP client. It has to be completely compliant to all HTTP RFCs. It must behave like a normal HTTP client should. And it should mimic the browser as far as possible. Web applications get used by users with browsers. Now when you're trying to crawl them, when you're trying to automatically use them, your crawler must function as close to a browser as possible. So it should be able to send HTTP requests, it should be able to receive HTTP responses, it should be able to parse the HTTP response header, like what is the response header that we got, what are the response codes and other fun stuff in there like cookies or redirects or whatever have you. And it should be able to parse through the HTTP response body or the response contents. You get these big blocks of HTML that you sift through. Sometimes people write terrible HTML. People write broken HTML which only works with IE. You may have tags which are not closed or improperly nested tags. So your crawler must recover and your crawler must be able to make sense out of all this. If any of this is missed, then the crawler is not going to work properly. Now, let's try and see how we can break crawlers, like the first premises in trying to defeat crawlers. So we have to answer these questions. Are you really a browser or are you a crawler coming to my site? Next we have to determine, are you actually a human sitting on a browser or are you a dog sitting on a browser? On the internet it can be anybody, even a dog. Crawlers have become smarter over the years since the early crawlers like wget. Now you have really fancy crawling engines which do a lot of things. Like Paros has a nice crawling engine built in, Spike, and a whole lot of other crawlers are out there. They're in commercial products, they're in freeware tools. Crawlers have they've overcome lots of hurdles so far, but even there's some limits beyond which they cannot go further. It's important to recognize this one fact that humans and crawlers use a web application in different ways. Just by noting the change of behavior, the change of usage patterns, if you're sitting on the server side, you can recognize if this is a crawler coming through your site or if this is an actual user pattern. In a crawler, you'll typically see depth first search or breadth first search techniques. If you look at your access log, you try to filter them out, you'll see the first page. Typically, crawlers implement breadth first search. So you'll see first page, then you'll see a request for all other links on that page, and then you keep on going to each link, all other links on the sub pages, and so on and so forth. So if you take an access log and try to classify it into a tree, you'll get a very nice breadth first search type of tree with every link being visited. A typical user session is not going to be like that. You're going to have different timing intervals. You're going to have different patterns of click-through. The user is not going to click on one page, then click on all other links, and then go to the next link, and then go to the third, then go to the fourth. So usage behavior greatly differs when an automated client is accessing a site or a user is accessing a site. So if we can now build mechanisms which detect this change of user behavior, then we can keep the crawlers out and only allow the humans in. So it's a fancy little concept. There's some tricks that I'll show you at the end of the talk, which I've implemented, and there's some more tricks that I wish to implement, and maybe this time I'll get a chance to pick your brains and get some ideas. Walk away. Okay. So let's see some differences between browsers and crawlers. Both browsers and crawlers must send a well-formed HTTP header request. If a crawler doesn't send them, it stands to just miss getting some pages. So if you want to differentiate between a browser and a crawler, you can check for some elementary things like, is this crawler sending a proper user agent, or is it is not sending a user agent, or is it sending some silly user agent like wget client or things like that. If you can do cheap trick-based browser detection. If you say, okay, the user agent is Mozilla or IE, I'll let you through. But this is very easy to build into crawlers. Almost all crawlers have custom user agent strings, so it's not a problem. That test will work for both crawlers and browsers. Then you need to look at HTTP referrers. Whenever you click on one page, and then from that page you click to another, an extra HTTP header information will be inserted by browsers. It's called the HTTP referrer, which tells you which page this link came from. You can build code so that if it does not detect the referrer, it can kick you off, saying, okay, you're just coming in directly. You're not allowed. But blocking things based on the referrer is also very trivial. Referrers can be spoofed. Referrers can be replayed. And almost all smart crawlers replay HTTP referrers these days. So that's so much about just simple header-based tricks to distinguish crawlers and browsers. Then we come to cookie handling and cookie replay. Now, almost all modern sites are driven, they have session cookies. They're driven with session cookies. You can force a constraint that if the request does not come in with a properly issued cookie, the request is completely denied. So then, if you're a browser, if you're using a browser and clicking through on a site, whatever cookies that are sent from the site, from the server, will be stored and replayed automatically as you go along. So the user-side test will not fail. But if a crawler fails to collect cookies and replay them upon request, then we have problems. Some crawlers replay excessive amounts of cookies. They're not very selective in what cookies they replay. They gather all cookies and they just shove all cookies back at the site. Sites will work because they only take the cookie they want and they'll discard all the other cookies. But we can write code to detect that if there are any other cookies coming in, we just say something fishy going on over here and not let the crawler in. The other trick to distinguish browsers and crawlers is to force HTTP compression. HTTP compression, it's specified in the HTTP RFC. If your client is capable of interpreting gzip encoded, gzip compressed HTML data, the server will send you some gzip encoded HTML data. What you can do is you can perforce send, always you can send gzip encoded data. The browser, regardless of whether it's capable or not, most modern browsers are, they will decode the gz. If you have a content encoding gzip, they'll decode the gz and render you the page nonetheless. Some crawlers cannot decode the gz, so they'll just take it as an octet stream and dump it and not be able to parse through it. Again, this is not a very difficult challenge either. You can always build a crawler with zlib libraries. They're publicly available. So now it's only a burden to the crawler programmer that they have to build in decompression libraries to carry on their work. So that's so far so good. So far crawlers can match up to browsers. But here's where crawlers cannot match up to browsers. One area is JavaScript, and this is a completely gray area. So far, I do not know of any crawlers that implement a full JavaScript interpreter. Jeremiah is grinning. Has he done it? I don't know. You've done it? No, yeah, it's not a 100% possible. You can pick through some of the JavaScript syntactically. You can build a quick and dirty JavaScript sifter and pick up links. But if you're generating links by adding variables or decoding variable strings, if you're programmatically generating links, then good luck trying to follow links. So it's a very difficult proposition for browsers. It's not entirely impossible. And the JavaScript interpreter is available in public domain. You can take it from the Gecko code, or you can take it from the Conqueror code and build it into your crawler. But it will cause you repetitive stress injuries and loss of hair while you're doing it. Be careful when you go there. But so one of the distinguishing factors between browsers and crawlers is JavaScript. But that's so far about technology. Now let's try and see the human aspect of things. So how do we differentiate crawlers and humans? Now that's going to be very easy. Humans are smart, or at least they seem to be smart. The first principle that you attack is a WYSIWYG principle. What you see is what you get. For humans, it's no problem. We have very good cognitive senses. We can discern what's in front of us. We can make sense out of fuzzy stuff. even if I read a block of code in, say, a language that I don't know, to me it looks like, okay, this seems to be some sort of an article or some human readable text rather than gobbledygook. Crawlers will not know what's coming at them. So if you try and attack this WYSIWYG cognitive-based principle, you'll be able to keep crawlers out and let humans in. Some of the quick tricks are, you have clear pixels on your site. These are like booby traps. If you click on a clear pixel, means you're not a human. Because human's not going to, it's a very random chance that you'll land your mouse pointer idly on one tiny little pixel on the background and then end up clicking it. And then if you do, well, I'm sorry, it's your bad luck. Chances of this happening, I think you'll win, the odds of winning $100 in this building are more than chances of this happening. Right? So if that happens, man, you're lucky. You should play the bigger slots, or you should try something else. Make money and don't bother with crawlers and all that stuff. Right? So for humans, if you can't see it, it doesn't exist. I mean, developers still believe that hidden fields are secure. Who's going to tamper with hidden fields? My data is secure. So people leave things alone. You don't go digging through everything. When it comes to crawlers, for them a clear pixel link is like any other link. You may have a submit button link, or you may have a hyperlink with an image. Doesn't matter what it is. A crawler will try to click through. So that's when you start bringing in the crawler police, saying, who are you clicking on clear pixels, and why have you done it 20 times in a row? Something is suspicious. So if we try to build code with this logic, we can very easily keep away crawlers. The second thing is, humans don't cause a lot of errors. They don't cause a lot of server errors when navigating through a site. Unless the site is completely broke and the developers have written it poorly, users will typically not force many errors through on any application. You won't see applications bombing on users with every click. Crawlers, crawlers are like these robots that crawl through mazes, and the robot will keep on going until it hits a wall. It's like, damn, now let me turn ahead and keep going ahead until it hits another wall. And they sort of bumble through the site. They cause many errors as they go along the way. So if you keep a count of errors, saying, okay, this is thus far and no further, you're out. We can easily keep crawlers out. Preventing crawlers from causing errors is a big problem. It's hard to solve this problem programmatically and computationally. For us, it's easy. Sometimes when you get an error message, even if the error message does not have the string error on it, we will make out that, okay, this is an error message, rather than some normal behavior. Crawlers won't be able to distinguish between disguised error messages and visual error messages. So crawlers will fail all these tests, and this is the premise which we will use to bog down crawlers. So now that we have some ideas to implement, we can do what we can do is to bog down crawlers. First, let's have a component that generates random error responses. So one of the first things you can do is create a little object which keeps on spewing out random responses every time and map it to your error handler. So every time you cause an error, something else will come up, some random stuff will come up. Now if it's a crawler and keeps on causing errors, it's not going to know between an error situation and an actual page situation. So crawlers will end up having false positives in error identification. When you generate the random error response, you can just keep on altering the HTML structure. You need not have it in the same format. This is a classic way of defeating my own page signature algorithm. So whatever I wrote until last year, I just shot myself in the foot, and then it's useless. I promised that I will release page signatures as a free library. I don't think I will do that now, because I just rendered my own research useless. I'll release it nonetheless. It's a fun little archiving thing to have. I did this once. As far as custom error handlers go, most web servers allow you to set custom error handlers. So for 404, you can say, okay, I want to have this page returned, or for 500, I want to have that page returned, or whatever. Now this custom error handler should be your random error code spitting object. So we're going to make the crawler crawl through all these errors painfully and painstakingly. And while they're crawling through, we're going to keep poking the crawlers and make them hurt along the way. It's like, try this barbed wire on for size. Okay, you're done with the barbed wire? Try some peat bog. You're done with the peat bog? Okay, let's try some iodine to make your wounds burn. So way number one to bog down crawler, keep throwing random hyperlinks, links that actually lead to nowhere. You crawl these links, you end up into an error situation, which presents you with more random links. And then you keep on going ad infinitum to such a degree that you actually miss or not touch upon entirely all the regular pages that are there. Even if the crawler painstakingly touches upon all the regular pages, they'll be lost in this slew of all sorts of random links. And one of the things I do is I generate random links with dictionary words rather than just random characters. So I have words like servlet and include and these type of verbs, www, root. So crawler thinks that it's getting lots of goodies and juice when it's getting just utter garbage. The other thing to do is to throw up actually non-existent error conditions. Instead of a 404, you can give a ODBC SQL error message. I mean, it's an error message. It doesn't really matter. Humans will just ignore the error message and go away, and a crawler will try to make sense out of their error message and end up being bogged down. You can throw up non-existent browsable directory outputs, or you can throw up non-existent HTML forms. It doesn't matter. You just write a few input tags and you write a form and an action tag and let the crawler try to decide what to do with it. So with this said and done, I think now what I'll do is I'll just come to some demos, enough of talking and discussion. What I've done, this is all experimental research. What I've done is developed a prototype in PHP, a crawler defeating mechanism as a proof of concept. And I've tried it against some of the really best crawlers out there, some of the crawlers that are out there and some of the crawlers that I've written. And it causes all of them to throw up utterly useless reports. So the whole idea is to illustrate the point that nothing is as good as manual analysis and testing. So now let me introduce PHP guard. PHP guard is implemented as a set of PHP scripts. There's actually 3 core PHP scripts. It's not anything miraculous or anything rocket science. It's fairly simple stuff. It's all based on randomness. You know, it's everything is about random values and odds. And you know, you spin a wheel, see if it lands on something, generate something. You toss a die. It's a nice place to be talking about randomness in general. We're in the midst of randomness, but the whole thing is the house always wins. You know, that's the non-random part of it. Okay. These PHP scripts, it's very easy to incorporate this code in any PHP-driven application. All you do is simply include this PHP code in the beginning of all your PHP files, like you would include a normal global resource. And it's going to PHP guard enable your web application. And these concepts are fairly simple, like I said. This implementation is in PHP. It can very easily be ported to any other web application programming platform, ASP, ASP.NET, JSP. In fact, I would actively seek collaborators on this. I am not a very good application coder. I can code in C very well. I can code in C++ very well. I can build packet filters. I can build operating system kernel stuff, but for God's sake, I can't build applications. I can only break them. So, I mean, when I release these PHP codes, please do not send me emails that your PHP coding sucks, because I declare it does suck. I can't write PHP code very well. Okay, so don't blame me. If at all you want to do something, clean it up and help me, and I'll give you good recognition, and we'll share a platform the next time we speak. Okay. So that should be good incentive enough. So very soon it will be publicly available, as soon as I can go back to India and have 4 weeks of time where I'm not interrupted by traveling. It's not happened since January 2004, I promise you that though. Okay, but it's soon going to happen because this is my last big trip for this year. All right, PHP guard, what does PHP guard do? One of the first things that PHP guard does is enforce strict session-based control. It uses PHP's session management APIs. you have the session APIs and the session cookies going back and forth. So the whole idea is, if you cannot replay cookies, you're out of the site. You cannot directly link to any resource in the website. You have to first go to the main page, get a cookie, and only then you are allowed to go through. And your session will be tracked as you go through. And these session tracking mechanisms are what's going to help us keep crawlers out and let humans in. The other trick that I want to implement with PHP Guard, I was trying this morning, but I couldn't get it to work. I was trying the output buffering and the gzip compression, but I think it kept bombing on me, so I said, okay, I just rewrote the slide saying coming soon, and it'll be coming soon. And the other thing that PHP Guard implements is a random error generator. It's a very, very nice random error generator. I'll just show you the code. The error generator generates varying HTTP response codes, and you can customize it to whatever codes you want to have generated. It'll generate a 404 code, a 302 redirect, or it'll generate a normal 200 OK code. So no matter what, if you make 100 requests for non-existent pages, you'll get 33.33% requests as 404, 33.33% as 302, and 33.34% as 200. I had to add it up to 100. As I was speaking, I realized I'm going to miss by 0.1. These codes are going to be structurally different all the time as far as the HTML goes. Sometimes they'll have lists thrown in, sometimes they'll have tables thrown in, sometimes they'll have headings or whatever not. So if you're trying to identify web pages based on structure, good luck, it's not going to work. If you're trying to use my page signature technique on this, it's not going to work either. And the error generation is based on dictionary words, and it contains lots and lots of hyperlinks. So if you get one error, you'll get at least 5 other hyperlinks to go and get some more errors from. It also includes error strings, as booby traps to capture crawlers. Crawler will report, oops, I found a SQL injection, and actually it's just a part of an error message. Another dirty trick is to also include HTML authentication forms, non-existent forms within these error messages. I'll show you all these things as we go ahead. I'll demo these out to you. So crawler will then try to brute force this form and just land into a complete pit, never get out of it. The next thing I've implemented is an error count limit. So the whole idea is to attack the premise that humans don't make many errors. So let's assume that for a normal user session, your allowable error count is 10. Okay, 10 is just for curiosity's sake, that you're trying to look around if this old page is there or not. We'll allow you up to 10 errors per session. If you go beyond this, then your session is blacklisted. Either you begin a new session and come in afresh from the beginning, or you live with this blacklisted thing. And when you get blacklisted, what happens is normal pages stop working for you. Then even if the page really exists, all you get back is an error. So then the crawler might end up listing all the real resources, but the contents will be error contents. And the other thing I did was just put a simple sleep call for every error response, and I keep incrementing the sleep based on the error count. So the crawler gets slower and slower and slower, and then it took a whole day to crawl 1,000 links with this sleep call put in place. So people just end up giving up. So now with this said and done, let me actually get into the nitty-gritties of PHP Guard. It's a trivial little setup. You throw it all into a directory inside your web document root. I've thrown it into a directory called PHP Guard. Wow, I have a laser pointer. I need not wave my hands. I need 2, actually. But I'll use this one, okay? If you guys want, or actually I can try to bounce some of these mirrors. I'll not do that. I think I'll damage my own eyes on the way back. Forget it. Laser pointers are bad medicine sometimes. Okay. So these are the files inside PHP Guard. What are the files? Index.html is a 0-byte file, so that nobody ends up, doing accidental directory browsing on it. Even if it is left unconfigured, you won't get the directory browsing. There is 3 files: error control.php. This is the file that is mapped to the error handler. This is the stuff that keeps on generating random error codes, random error contents all the while. This is like the crux of the whole thing. And then we have two other files called set session and force session. These are the files that actually do the session control. And if you bypass the session control, then you're out. These are the files that also keep a count of how many errors you've done, how many errors you've committed using session management APIs. And if the error count is more, then it's going to throw you into a completely different area, in completely random areas. And then lastly, there are two files called clearpixel.php and clearpixel.gif. These are seed files for crawlers. These are seed error files. They'll populate your HTML pages with a few error links, so that if a crawler comes by these links, it's going to land into them. And then the fun begins. Okay. To configure it, what you do is in your httpd.conf, you can set the error document. This is all in Apache. In IIS, it's going to be different. In other servers, it's going to be different. But at the end of this, I think when I go home, I'll have a nice paper written up on this with all the tools included and procedures included. And then you guys all can contribute to this, because I'm not an expert in other web servers. So you have the error document directive. You can map different error codes. So what I've done is I've just mapped 404, 403, and 500 to errorcontrol.php. So any of these three errors will lead to errorcontrol.php being invoked. And then in the application, actually then I need to go ahead and insert code in the application. So in the application, there's two parts. There will be the first starting point of every application where things begin, where all the sessions get initialized and stuff. So for the starting application, you have to include this directive, phpguard set session.php, that one. And then you can have the rest of your code go along. At some point, before you start generating the actual HTML, it would be a good idea to insert this link, insert this include directive as well, called include phpguard clearpixel.php. So that's just going to start off your HTML with a few erroneous links. It's optional. It does not. You can write your own for that. It's not compulsory, but it's a good thing to seed the crawlers with a few errors. Then for all other PHP files which are not the starting files, all you do is you include a phpguard for session.php. So this will do the session checking. The set session will set up the session, and the force session will do all the session checking as it goes ahead. So with this simple stuff, we can set up phpguard and have it deployed. So now on to the demos. Okay, any questions so far? Any queries or any questions that pop up to mind? Anything that you would like me to touch upon? Yes, your question. The question is, do I have any measurement of the overhead this technique has? Is that right? Like the PHP guard technique, how much overhead does it add to the whole response? No, it's not going to make the user experience any slower, probably by a millisecond or so, the time it takes to generate random numbers. That's about it. Nothing else will be slowed. In fact, your network connection and your reading and clicking abilities will be way slower than any performance degradation that you have. There's not going to be any application degradation in this. In fact, if you look at the code, once I make the code public, it's really cheap code. I'm ashamed to admit that. It's hardly anything. Yes, your question. Actually, let's revisit this question after the demos. I think a lot more is going to fall into place. To answer the first part of your question, I have tested it with lots of crawlers, and I'll show you some of the crawler reports as well. All these crawlers go for a toss. So that's nutshell answer. Anyway, so let's get to the nitty-gritties. Okay, now I'm having a problem. I do not have the same screen over here. So tell me if I make any typos, okay, because I can't read from that mirror, and I can't crane my neck back like the 36th chamber of Shaolin to read the screen effectively. Okay. So shout if I bumble, okay? Typing in the wrong window already. Okay. Okay. So can you guys read this at the very back though? Are the fonts readable or should I enlarge them a bit more? Forget the stuff in blue. Blue will go away. Blue will go away. Blue's gone. Okay. Right. So there we have it. We have a simple site. For those of you who took my class in the past 2 days, you'll be familiar with the whole DVDs for less site. And I have integrated PHP guard into a sample PHP application. So let me show you the site. The site has okay, these backup.sh and backup.zip are not a part of the whole thing. So you have index.php, which symbolic link to catalog.php. So catalog.php is your starting point. Then you have about us, you have shopping cart, you have catalog as I showed you. You have details, you have privacy, and you have rebates. Okay. So let me show you this site itself. Here's the site. Here it is. So here's a normal site. You can click on the catalog. It will show you the catalog. You can click on a link. On the details page, it will show some of the details. You can add an item to the shopping cart. It will show the shopping cart. Then some of these items have a rebate coupon. So rebate coupon will pop up, and then you can mail it in and wait forever to get your discounts. That is the classic scam of the past decade. Mail-in rebates. Yeah, right. Then you can do a view cart to see what you have in the shopping cart. You can click on checkout to it'll redirect you to an SSL site with a dummy certificate to make sure everything's secure. You can fill out the form. I can't read what I've written. Anything. I'm just going to skip through this. Don't copy down my credit card number, it's secret. Okay. Fill this in and say submit, and there I have it. I've generated an order, and life is cool, and the application works. Okay. Now, let's see. Let me open up the browser again, and let's go back to the application. So here we have the application back. Now let me try and force some errors and see what happens. We have PHP guard in place, so I'm going to just spit up a non-existent link. Right. So here we get some response. We get some funny quotes, and actually these are generated from my friend's website. Friend of mine, Nirav, he has a website called Nirav's Quote Factory, and all these quotes are from there. So I have this huge array of funny quotes that I keep generating from, and then some of the words in these quotes get hyperlinked. Like this word, what's that word? Yeah, bachelors. That is hyperlinked to something that I can't read. But so it's hyperlinked. If you click on it, you'll get some other non-existing word. Now all these words are dictionary words. They're not random ASCII character data. So it's to a human, if you all of a sudden if you get this screen within your browsing experience, for a while you'll read the jokes and amuse yourself, but then you figure out that okay, something wrong happened. This is not what my banking application should be doing. But oh well. So you try to either get back to your business, or if you're really interested in reading the jokes, so you keep on clicking and reading more jokes. Now sometimes you'll even get this response. This is actually a very proper 404 response. Now below I have this debugging information over here, which says your error count is 4. Every time you keep on going ahead, you keep on incrementing the error count. I think now the error count is 6. Okay. I'm sorry, I just can't read at this angle. But, and over here, notice you have these HTML authentication forms. You have this username, password. So crawler is going to try and brute force these. There are some error messages embedded in there. Like one of them I can see is this cold fusion error message. And then, if you have the crawler seeking out error message strings, it's going to throw this in the report saying, your site has a cold fusion problem. Okay, my site doesn't use cold fusion. How's that? But that will happen as well. Now, before we exceed the error count limit, let's go to the. I've set the error count limit to 10. So up to 10 errors, I'm fine. The minute I commit the 11th error, I'm gone. Okay. So now over here, I can always go to the rest of the site. It's still functional. I can use this and life goes on. Now let's go to the other window and commit some more errors. Shall we? Reload this, there's another error. I click over here, there's another error. What's the error count now? It's 11. It's 11, okay. Now let's go to checkout. It does throw me to the SSL site, but now the site's non-functional. Now even if you have harvested all the links and you keep on clicking through the links, you'll always get errors back. You can go back to the main page, you can click on another thumbnail, you'll get an error. So now, after 10 errors, the site has become completely dysfunctional. It's only going to show you random stuff. So that's PHP guard in a nutshell. Let's try to do some netcat tricks on it. I'm sorry? How a user starts a new session. Okay, close the browser. We open the browser again. And the session is just it's a session identifier. So in fact, if you use a different browser, you use IE and Mozilla, the Mozilla guy will be just fine, and the IE guy will have problems if they're committing problems. So these are just, you don't really have to do anything. You're back to normal. I am not looking at any IP addresses. I'm not looking at the source IP addresses. Otherwise, everybody behind a proxy server will get blocked off. That's not a very good thing to do. Okay, where's the mouse? Now if I come back here and things are fine. Things are just okay. If I try committing some mistake, let's see, if I try forcing some 404s, then, okay, so far the error count is 1. Can go back and force some more errors, and then once the error count hits 10, it's going to be the end of it. Okay, so 5. Okay, that was a. What is it now? 8. There it is. At least I thought this would amuse you guys, if not anything. Okay. Now the site's blocked. Now you've really done it. Okay, you can go to the main page. That will exist, but everything else is just gone. Okay, so now let me show you the code. That's the fun part of it. Yeah, I'll release the error messages. Sure. That's the fun part, isn't it? Okay. So here's the contents of the PHP guard directory. Wow, I hope I don't overshoot my time. This PHP info is not a part of the PHP. It's just meant for my debugging purposes. Okay. But let me show you error control.php. So here you have it. You have certain variables that you can set. You can set a whole. These are all the HTML structures that I use when generating the error pages. You can add to this. You can add the beginning and ending tags, so you can generate different types of HTML tags. You have different headings, fonts, extensions. I love to give crawlers different extensions so they try different sorts of attacks on them. Then I have these commonly known directory prefixes like report, logging, source, include, data, graphs, web apps, servlet, and then the crawlers go try everything from there. Then some nice SQL injectable parameters like ID, SKU, item, PG, which have integer values in the parameter. So this not only generates hyperlinks, it generates hyperlinks with query strings and input fields and everything. All good masala for the crawler to test. It has these path prefixes. Sometimes crawlers say, oh, we have a path disclosure error, saying we got var www.html coming up in an error message, which is not true. And then I have this sleep flag is equal to 0 over here. I do not, I've disabled the sleep functionality. I can enable it to cause, to cause response slowdown when you're repeatedly crawling. And then beyond this, you really don't need to change anything. You have all your PHP code. There's all these random things, and this is some. This is where I have the quotes array as well. Okay, this tells you how smart of a PHP programmer I am. I don't even have it in a separate file. Anyway, but that's not the point. Then I have this one line called set session .php. All it does is just sets a Boolean variable begin to indicate that session management is on for the rest of this, and all the other pages have force session. So all these pages have force session, which will check for the existence of the session. If the session does not exist, you're redirected back to the original location, and the session is destroyed. New session is created. And if the session exists, then over here I check for the threshold of number of errors committed. If the threshold is if the threshold exceeds, then you're always redirected to some random URL. If the threshold is below the limit, then you're allowed to go through with the rest of your application. So you include these two files in the beginning of every PHP, and you're good. Now let's see the Apache config file. I'm now isn't it going on till 3 o'clock or? Oh, I call it. Okay, really quickly, I will try to accelerate myself. Okay, so you have this. You have a error document. Over here, I've mentioned the error document. This is where I've set the errors in. Let me do a quick demo of wget. Or actually, I'll just show you some of the reports because we don't have time. You better believe it. This is going to stop crawlers dead in their tracks. Now, let me just show you the reports. I generated a report with actually a prototype crawler that I wrote. While this report is being generated, it's going to take a long time for the report. It's a 10 megabyte report. But I've tested this with wget. I've tested this with Paros. And the report I'm going to show is from an experimental crawler that's not yet been released. I wrote the crawling engine for that. So anyway, concluding thoughts, you definitely need to know what you're doing in this whole automated testing game. Read good books, that's a shameless plug. And some of the new goodies to look for, it's completely unrelated to the talk, but if you're interested in my research and my work, The new version, there are so many different attacks possible, and this is found, that's not found. Anyway, the crawler has gone for a toss. But any questions so far? Any? Yes, your question. Yeah. Yeah. Correct. 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 Okay. To defeat that, you cannot actually keep a set of links handy and then re-enter the website, because the session will have expired. This code does not allow you to link directly into the site at all. If you link directly into the site, you'll be thrown back to the main page saying, start at the beginning, buddy, you're not supposed to come right in here. So even if you know the tree, you can't hit it. You can go up to 10 links far, and that's about it. Yeah, you can do a depth analysis too. But once you've committed the number of errors, then even the original links will be all error codes. So yeah, sure, this is not infallible. Okay, this is not a be-all, end-all thing. This is a, like I said, it's a cheap trick, but I managed to present this cheap trick at Black Hat. So how cool is that? That's a cheaper trick too. Yeah, sure. And in fact, you know what? Once the code goes live, definitely let me know if you've written up crawlers. Like I said, this is going to open up new areas of research. So go for it. Hit it. Anyway, I think, yes, Jeremiah. Dangers to the data after logging in, is that what you said? I get it. I personally, the more crawlers that I've developed, I know that it's a bad idea to crawl links. I hate, as much as I've made my money by developing crawlers, I do not like crawlers very much. Like, let's say you have an email composition form. You compose an email, delete an email, reply to, and you start clicking every link in there, you're in problem. In fact, for all the crawlers that I wrote, I always made sure that after the authenticated point, do not crawl further, because that's going to land you into data tampering problems. I even don't do the or 1 is equal to 1 test, because once it landed into an update query instead of a select query, and the whole database was replaced. Yeah, that would do it. Any other questions? Did I overshoot the time? Am I? Okay, we have some time. Now, why was I kicked out before? Okay, thank you.